Hello campers, Dr. Dickey here.
We've gotten to the point where we need to talk about grounding. How I did my grounding, why it was wrong, and now what I have to do to correct my grounding. So to get NEC compliant, National Electrical Code. So according to the National Electrical Code, your panels have to be grounded, all of your panels. And the panels I have are anodized. That means it's formed an aluminum oxide layer on the outside. And aluminum oxide is not conductive, so it has a lot of resistance. But you have to penetrate that insulation to be able to ground them to the aluminum underneath. But there's a couple of caveats there. And one is, of course, you have to penetrate the anodization. That's fine. But you also can't bond copper directly to aluminum because copper and aluminum, I don't remember the standard reduction potential differences, but they have significant standard reduction potential differences, and they will oxidize, they will self-react, and that will cause corrosion. Corrosion will increase resistance, which means they won't be grounded anymore. So that's a couple of things. So to be able to do that, you have to have special clips, and these are the special clips. I'll show you. So I don't know how well you can see this, but you see the little divots up here, the little tits, let's call them peaks. When you put that onto the solar panel and you crank down on it, those little divots there will penetrate the anodization and get to the aluminum underneath and form a bond that you can then hook a copper wire to. These are stainless steel. And they need to be stainless steel because that way the stainless steel to aluminum doesn't tend to self-react. And the copper to stainless steel doesn't tend to self-react. So if you put this as a barrier between it, you get grounding to the aluminum underneath, and you can hook a copper rod to it, and then you won't get reactions between the two, and so it should reduce the corrosion that you get over time. So that's what I'm doing. In addition, you only want a single ground point now. The way I did my system, and I'll show you. First I'll show you the copper setup with these, and then I'll show you what I did with my system. So you can see right there, I've got one on a panel. I've got another one on a panel, and there's a 6-gauge copper wire running between them, and then that's going to be eventually bonded to this strut. And that goes over here, and eventually that's going to come up and then down and get bonded to this pole, and then this pole will get bonded inside the combiner box to the ground bus bar that's over here. So that will be for all the panels. I've got those on the upper panels and on the lower panels. So you can see them on the upper panels. Haven't got the copper rod run through here yet because I haven't gotten to that point. So what did I do? So I looked at my array as being an isolated system. That is, this was isolated, the shed was isolated, and then the house was isolated. The only connection between this array and the shed was the DC positive and negative wires that I ran through the conduit for the little dig that I just did. Just got that done. And so I had a ground rod. Let's see, I can probably dig it up. It's right here. A copper ground rod. That's what that is right there. That right there is a copper ground rod. I had a copper ground rod there. I had 6-gauge copper running up and into the combiner box. So this was grounded. I knew that the combiner box had to be grounded, the array had to be grounded. I didn't know the panels had to be grounded. Since they were anodized, I didn't think so, but they do, and that's what I'm doing now. But additionally, I had another rod, and you can see where that rod, where the wire comes out of that rod down there. I have this copper wire that came out of a rod that's right down here. Oh, let's see if I can dig down to that rod. It's not down very far. There's the top of that rod right there. These are 8-foot copper rods, and they've been put down into the ground so that they make a good ground contact. That came into the shed, and that went, it's a very cloudy day today, so I don't have a lot of light. That came in and goes to the solar inverter, the solar charge control, the midnight solar charge control. For the inverter, the split phase inverter, it has a ground that runs on the output for it that goes to the house and is bonded to the ground rod that's in the house system. So I looked at this as being bonded to the house, therefore it's ground. This was bonded to a rod, therefore it's grounded. And the combiner box was to another rod, and therefore it was grounded. And the array was grounded, because the wire coming up to the combiner box also was attached to the lead there. So everything was grounded. Well, that's what I thought. Well, clearly everything was grounded. However, there's some problems. Things I didn't know. One is, you also have to, by NEC, you have to have a ground fault interrupter system. That is a system that measures a ground wire, and if any current flows on that ground wire, then obviously you've got some problem somewhere and it'll shut the system off so that no one gets shocked. The way the ground fault interrupt system, GFI, system works in the midnight solar, and in, I think, most solar inverters, is that it bonds the ground to the DC negative. See, I didn't realize that. Bonds it to the DC negative. So what does that mean? Well, that meant that there was a connection between the array and the solar shed, because the DC negative that flows from the panels was flowing right into the solar inverter, and that was bonded to ground. So there was a ground out here, and there was a ground that I had put in the ground over there. In addition, because the DC negative then goes to the split phase inverter that goes to the house, that also grounded the case, and then therefore connected the ground rod that I had in the shed to the ground rod in the garage that went along because of the DC negative connection. That's not a good thing. And the reason it's not a good thing is the rod that I had for the array out here, and the rod I have for the shed, well, they're at least 150, maybe, I don't know, 120, 150 feet from the ground rod in the house. And that's a problem. And it's a problem from the fact that if lightning strikes my backyard, lightning being, several 100,000 volts, and it strikes the ground, which is what it does. We'll talk about lightning a little bit more in a second. So when lightning strikes the ground, it will set up a voltage gradient across the ground. So these rods in the back, if lightning struck somewhere near the array, that would put an extreme potential on that ground rod that I had for the array. Well, since it's bonded to the ground rod that's in the garage, which is much, much farther away, we're going to get a huge voltage difference between the ground rod in the backyard and the ground rod in the garage for the electrical system, the grid electrical system. So what's going to happen? Well, if you got a huge voltage difference, you're going to get a huge current flow through that, and that current flow would go through my equipment to get into the garage. And obviously a huge current flow in my equipment, not a good thing. So I have to eliminate the ground rod for the array, which I already disconnected it. I have to eliminate the ground rod that I have in the shed for the midnight solar, the solar inverter. So if I eliminate the ground for the midnight solar connection, then the only ground connection between the array and the shed would be through the DC negative. Well, I don't want that. I want to have a separate ground run. Oh no! What does that mean? That means that the little dig I just did and dug up that conduit and ran the 4-gauge positive and negatives, I now need to run a ground wire, an 8-gauge ground wire, which I have. Here is my 8-gauge ground wire. I'm going to run that from the combiner box into the shed. That's going to be connected to the midnight solar. I'm going to put up a ground bus in there. And then I'm going to connect the midnight solar, which has the ground fault interrupt system. That's going to be then bonded is what the electricians call when you attach something that has the same potential, having the same potential. That's then going to be bonded to the lug on the back of the inverter, which grounds its case and then bonds that to the ground that runs in the 3-conductor and a ground 6-gauge that I ran in the big dig into the house to the panel, so that the only ground rod for the array, the shed, and the service in the house will be the ground rod in the shed, in the garage for the service to the house. So I'll have a single ground point. Therefore, if lightning strikes back here, they won't set up a huge potential difference to have the current run. There'll be a single point ground, which is what you want. I went back and forth about that, but I finally am convinced that that is the correct way to do it, single point ground. Now you say, but wait a minute, what if lightning strikes your array? Then it's going to travel that route to get to the ground rod over there. Well, that's somewhat true, but if lightning strikes the array, no grounding that you're going to do is going to really help. There's just too much energy in a lightning strike. So you want to prevent lightning strikes. How do you prevent lightning strikes? Well, it turns out the way lightning works, and I'm no expert at lightning, this is just my understanding. The way lightning works is that the clouds, of course, build up a huge charge, and most lightning is cloud to cloud that neutralizes it, that dissipates the charge. But the clouds build up a huge charge. Then the ground builds up a charge, and as that ground builds up a charge, it eventually sparks up to the clouds, and then that makes the connection that the clouds then have their pulse come down and hit the ground. So the best way to prevent a lightning is to not allow that charge to build up on the ground. So, with the array grounded in the garage, if a charge begins to build up in the ground back here, around the array, that array will dissipate that charge off, and therefore will not have as likely to have a lightning strike as it would be if I didn't have it grounded. So, it does work. I mean, that should take the problem off. So the other thing I'm going to do, just to make sure, even though my array is all metal and it's all bolted together and it's all basically at the same potential all the time, I'm still going to add grounding straps between the 4 12-gauge struts that have the original 4-gauge, the 12-gauge struts, that when I'm going to bond those with a strap to the 1.5-inch galvanized pipes, and I'm going to bond those together, and then I'm going to run straps between those 12-gauge struts and the 14-gauge struts that go east-west that the panels actually rest on. So everything will be bonded with straps, and everything will be bonded together, and I'll have a ground going from the combiner box through the little dig into the shed. That will bond the ground fault interrupt system, and then also bond it to the inverter, which is bonded to the 6-gauge wires that are running into the panel in the house to service to ground everything. So that's what I have to do. So, do I have to dig up all that little dig that I just did and do it again? Maybe. Hopefully not. I've got a nylon fish that is used to fish wires through the conduit. And the conduit's 1.5 inches. It's got the 2 conductors in there, but there's a lot of room, so I'm hoping I can get that fish to go through the conduit, hook up this 8-gauge, and pull it back to this side, and then be able to do all that. So that's what's going to be done. I'll show you snippets of doing it and show it when it's done. But that's the whole thing about making sure you're at NEC compliance for your solar array. That's the plan to do that now. All right? So, that's what we're going to do. So here's the fish. It's 40 feet, I think, 15 meters, something like that. And it's nylon, so it's not going to damage those lines when I try to feed it down through. Whether it's going to make it from here to the shed, I don't know. I hope. I do know that fortunately I did not glue the last two elbows that go into the shed, because they were very well connected, and they're in a way that water couldn't get in there no matter what. And I wanted to keep the possibilities of maybe doing something like this. So I've got, I don't know if you remember from the dig, so it goes down 90, goes over 90, goes that way 90, and then up. So I've got a bunch of 90s to go. I'm not going to have you sit there and watch all this, though. I gave it a try. I'm not even getting past the first 90. So there's no sense. I'm just wasting my time. I'm going to have to dig it all up again, and then put all new conduit and run my ground through there. Ah, boy. Oh well, not the end of the world. It isn't the longest run in the world, so that's what I'm going to have to do. The Little Dig Part 2 redo has been redone, and it's all in there. So you can see, now you can see that grounding rod much better right there. And so that is this, I don't know if you can see this, the ground line here bonded to the ground in here. Ground line, ground. That runs through there, goes into the shed, comes through the same place as the other conductors, and then it's bonded to this bus bar, and that bus bar leads into the midnight solar for the ground fault, and it goes from the lug on the back of this inverter, which is bonded to the ground, which goes into the panel. So the whole system now is all grounded to the ground in the garage. So the only thing left I have to do is I have to do all my panels, get them all bonded to the array, get the array all bonded together, and then that will be brought in there to the bus bar in the midnight solar as well. So that's what I'm in the process of doing. So I've got these panel bonds, but I want to bond both of these copper rods to these, I think they're 12 gauge struts. And then of course I'll bond this 12 gauge struts to the 14 gauge struts, so that everything and all that will be bonded to the 1.5-inch galvanized pipes that hold everything up. So everything will be put together as to one system. That's what I'm doing now. These are the grounding lugs I have. They are aluminum, but they say they are tin coated, so that should prevent your corrosion. And I'm going to be putting them all in with these self-tapping screws. I got a bunch of these self-tapping screws, so I'm just going to drill a hole, drill a self-tapping screw in, and then put the copper wire through that to be able to bond it up there. That's the plan. Well, these are supposed to be self-tapping, and they are. So I just used the self-tapping properties, and that did okay. Let's just put the copper in there, pull that back, give it its bend. And I'll torque those down to specs. Okay? And I'm just going to continue to do that. Alright, just an update to show you what I have done. So
There's the 6 gauge. It is bonded to the 4 main, I think they're 10 gauge struts. And then you can see where I've bonded the 10 gauge struts to the 14 gauge cross struts. And it's bonded to the metal here. Again, I've got bonds here. The wires goes through the panels. Another bonding strap for the crosses. Bonding strap. The 6 gauge copper wires from the panels that are also bonded to the struts comes up. There's 2 of them. I have combined them together here. I have combined them together here. The one terminates here that's bonded to this pole. The other one is bonded to the pole and then continues into the combiner box. I'm not going to open the box, but that is then hooked up to the grounding bus bar in there, which is also part of the negative, which is bonded to the house system. So it's all been hooked up, it's all been hooked together everywhere. Like I said, I bonded these. All the cross rods are bonded. I even got those 2 front panels. I don't know if you can see from here, but see they're bonded. The panels I'll show you. 2 panels that are on that will go to my lithium iron phosphate system when I get it. Get the cells in. See, they have both of those panels have now been bonded to this, which is bonded to the system, so that everything has been grounded. So everything finally is grounded the way it's supposed to be grounded. The conduits are all down 2 feet and buried like NEC requires. So as far as I know, I am compliant, finally. And of course we got a nice cloudy day today. I'm not going to get much production, but that's the way it goes. All right, so see how cloudy it is. So thanks for watching, and see you in the next video. Hopefully that's when my lithium iron phosphate cells come in. They should come in the next 2 weeks easy, because it's not a week from yesterday is going to be Christmas. Merry Christmas. See you next time.